Good morning. I just wanted to go over this worksheet with you a little bit. I think it's pretty self-explanatory, but that doesn't mean that we can't do a little bit of it together. So what it's talking about are environments, habitats, and microclimates. So we think of a climate for a whole region, like a big desert or the rainforest. But what they're going to get into here are something called microclimates. And you can look up the difference between a climate and a microclimate. You can just find that online. But basically what a microclimate is think of the underside of a rock. That's going to be a microclimate. The shady side of a tree, that's a microclimate, a very small space that is different in conditions compared to those things around it. And this is why abiotic factors, non-living factors, are so important to habitats and life, is that they vary and they can make conditions better for things that are living in certain places. So take a look at this one here. We've got a desert environment, and just as you would expect, they've got temperature in all these different places and humidity, the amount of water in the air. Places like this burrow underground, not surprising, are a lot cooler than it is on the surface. Something that could be surprising to you is what it's showing here is that the burrow has higher humidity than on the surface. So there's more moisture in the air down there. This is going to help living things get through hot, dry days in the desert. Even under a rock is showing, like, if you flip over a rock, you see insects or lizards or other small little creatures that are living under there. Well, there's a good reason for that. Temperature's a lot lower and the humidity's higher. So it's a much better environment than on the surface. So those are the things you're thinking of as you answer these questions, okay? The next couple of pages are all doing the same thing. So next we look at a tropical rainforest, and it's going to ask you questions about the tropical rainforest. Try and think of these things as if you were there looking at the forest. It shows that, like the first part says, how does the gradient change from the top of the canopy, so up here, down to the ground, the leaf litter? And it gives all the stats over here. Well, let's look at wind speed. Wind speed up at the top is 15 kilometers per hour. It's very windy. But wind speed on the ground is 0. Even just above the ground is only 3 kilometers. So the wind speed decreases as you go down. And you can think of that if you were ever in a forest or even a park, really. You can see the tops of the trees swaying back and forth, but down on the ground, it's not as windy. The wind's not blowing as much as it is moving the tops of the trees. And you'll see some other stuff about humidity. Remember, that's how much moisture is in the air. But you can link some of these things too. The amount of wind could be linked to the humidity at higher levels of the forest. Maybe that moist air gets blown away, but down here at the bottom where there's a little river, there's some moisture down there already. It's not getting blown away. There's less light, so there's not as much light intensity to evaporate the water. The temperature is most likely going to be cooler, even though we don't see that here. It's most likely going to be cooler down there, and that's going to give a higher humidity, higher moisture in the air. So these things all play off of each other. You have to think of how one thing can affect another. This one has some tide pools, so think of the ocean. You can go to the ocean off the California coast, and there's all these tide pools. Well, it has the low water mark here, and that's the average for as low as it gets. And then there's a high water mark, the average for the high tide. And as you would expect, you have different temperatures all along there, depending on how exposed they are, how often the water gets refreshed, how long they spend away from the ocean, like if you look at this highest spot up here, the exposure is 12 hours before you get any new water that goes into this one. But down here near the low water mark, this pool only goes about 4 hours before it gets some more fresh ocean water in there. And these change things like temperature and oxygen. When it talks about oxygen, you have to think about what uses oxygen. Is that oxygen getting refreshed by new ocean water? These are some of the things that can change in these different areas. So these are our microclimates. So let's see, describe the environmental gradient from the low water mark up to the high water mark. And let's look at something like dissolved oxygen. At the low water mark, it's very high, 100%, and then it slowly decreases to 20% at the high water mark. So something like this dissolved oxygen decreases from the low to high. And then finally, it's got this lake here, and these lakes, and it describes this in the paragraphs up here, but these lakes are stagnant. They don't have a lot of water coming into and out of them. And so what happens is this top region doesn't mix very much with the bottom region. So this water down here, it doesn't mix with the warm water on top, so it stays very cool. But also you notice that there's not much oxygen, because that oxygen down here gets all used up, and there's no new oxygen coming down from that top layer because there's no mixing. And that affects the different microclimates and habitats you find within this small lake. All right, if you have any other questions about this, let me know, and we can go over it together. Thank you.